Welcome to another episode of Tech Talk Tuesday. I'm your host, and today we're diving into the fascinating and a bit scary world of security vulnerabilities in AI, specifically through the lens of a project called the Damn-Vulnerable Context Protocol, or DVMCP for short. So what exactly is DVMCP? Well, it's a deliberately flawed educational tool that's designed to showcase the vulnerabilities that can exist within the Model Context Protocol, or MCP. Imagine if cybersecurity experts sat around the table with developers and they decided, let's build something that's intentionally full of holes so we can learn how to patch them. That's pretty much what DVMCP is all about. Now, before we jump into the more technical details, let's clarify what the Model Context Protocol, or MCP, actually does. MCP is a standardized protocol that helps applications give context to large language models, those fancy AI systems we often hear about. MCP separates the job of providing context from interacting with the AI, allowing applications to expose resources, tools, and prompts in a structured way. It's quite the clever system, but as you might expect, it has its share of security concerns. And that brings us to the core of today's discussion, the vulnerabilities. The DVMCP project features 10 challenges, each one ramping up in difficulty. Think of these as levels in a video game. Each level teaches you something and potentially gives you a nasty surprise if you're not careful. For example, one challenge focuses on prompt injection, where malicious inputs attempt to manipulate AI behavior. This is a huge deal because, if the AI starts doing things it's not supposed to, that could lead to some unpredictable outcomes. Other challenges include tool poisoning, where hidden malicious instructions lurk in tool descriptions. Imagine trying to use a harmless-looking tool that, unbeknownst to you, is actually backdooring your system. Yikes! And then there are threats like excessive permissions, rug pull attacks, and even remote access control. Just think about the implications here. On a broader scale, if an AI system can be accessed or controlled without authorization, it raises very serious questions about data safety and user privacy. So here's a thought-provoking question for our listeners. How much do we trust these AIs we're integrating into our lives? It's a bit of a balancing act, isn't it? We rely on these powerful tools for tasks ranging from mundane queries to more complex decision-making, yet they could be vulnerable to attacks if not implemented correctly. Let's dig into some specifics. If you look at the easy challenges like basic prompt injection or excessive permissions, these represent the low-hanging fruit for attackers. Yet, as you move to the medium and hard challenges, like malicious code execution or multi-vector attacks, it starts to feel like a high-stakes game. The sophistication of these attacks is what really drives home the point about how imperative it is to maintain a strong security posture. The creators of DVMCP, led by harishsg993010, emphasize that these vulnerabilities are there for educational purposes only. So no one should think about implementing these pitfalls in production systems. It's a classic case of, don't try this at home. Always follow the security best practices when it comes to deploying these systems. As we wrap up this deep dive into the Damn-Vulnerable Context Protocol, let's reflect on some key insights. We've learned about the potential pitfalls lurking in models and their protocols, the importance of security testing, and the need for ongoing education in the field of AI and cybersecurity. So here's a parting thought for you. Next time you interact with an AI system, take a moment to consider what is happening behind the scenes. Are there vulnerabilities that could be exploited? And what are the best practices in place to safeguard our data?